Hi, my name is Martin, and for Group A, I'll be demonstrating the web application development for a smart DCU web project. I will show how it fulfills the various requirements for a successful web application by demonstrating functionalities and delving into the testing procedures conducted to ensure its quality. So these are the various roles and responsibilities of all our team members. Introduction. The Smart DCU Dashboard is a web application designed to leverage sensor data to provide valuable information for a smart campus environment. The tech stack used for this project was HTML, CSS, JavaScript, Java, and it was deployed on a Tomcat server. The purpose of this presentation is in submission to my role in the demonstrating and testing procedures to ensure the quality of the web application. This will be demonstrated by using a voice-over screencast and presentation. Web application development cycle. To fulfill the requirements of the project, Group A developed and used the Agile methodology. We specifically use the Agile methodology, which involves breaking the project down into smaller phases, and this allowed for testing and development of each of the phases and continuous development to successfully complete the Smart DCU dashboard. Understanding the target audience and their needs is crucial for any successful web application. The Smart DCU dashboard addresses audience by providing a data visualization for temperature, humidity, and room sensor occupancy, and other metrics relevant to a smart campus environment. This may allow users to make informed decisions and optimize their campus experience. Web page design and navigation. The Smart DCU dashboard features a clean and user-friendly interface. Readability and ease of use was prioritized by using clear fonts and a consistent color scheme. Intuitive navigation menus allow users to easily access different sections of the dashboard. As you can see during the demonstration, the Smart DCU dashboard features a clean and user-friendly interface. Readability is prioritized and ease of use by clear fonts and a consistent color scheme. HTML provided the foundation for structuring the web page, and CSS was used to style the visual elements for a cohesive user experience. The user menu allows for effortlessly accessing different sections of the dashboard, such as data visualization and user profiles. Front-end development is the process of creating the part of the website that the user will interact with directly. The user interface and user experience that the user will encounter. This section will demonstrate and test how the front end was developed for Group A Smart DCU web application. HTML is the standard markup language for creating web applications. It describes the structure of the web page by defining the content and layout of the website. In our web app, HTML was used to build the foundation of the user interface. I will now discuss the HTML code, theme.html, and test how it relates to the web page. In theme.html, elements like header, nav, ul, line, div, h2, h3, and p create the overall layout for the header section, navigation menu, team section, and individual team member details. As you can see, in the divider class team member, a team member name is described using a header tree, and then using paragraph, we have their roles and responsibilities. To test this onto the website, we can see it relates to the code. The name is defined using header tree, and their roles and responsibility is defined by using the paragraph, and it relays onto the website. While HTML acts as the foundation of the website, CSS takes care of the styling the visual elements defined in HTML. This will include the font styles, colors, background layouts, and just the overall presentation of the web page. This is similar to the skin and the skeleton. CSS is the skin, it's what you can see on the outside, and HTML is the skeleton, what you can't see in the inside. I will describe this now going back to theme.html and the web page. As you can see in theme.html, the CSS styling is defined using style within the HTML file to control the visual appearance of the page elements. You can see visual properties like font family, font size, color, margin pattern, and background color. These styles create the visual presentation of the theme page, including the layout and of the team member information boxes. As you can see, the CSS style using the properties displays and creates a visual representation of the theme page onto the website theme.html. HTML and CSS provide the structure and style. JavaScript adds the interactivity and dynamic behavior to the web page. The toggle login function does this by checking if a user is stored in the local storage. Based on the presence of a user type, the function dynamically updates the text and functionality of the login and logout button. As you can see in script.js, the toggle function checks if there's a user logged into local storage. Based on the presence of a user type, the function dynamically updates the text and function of the login and logout button. If a user is logged in, the button displays logged out. If a user is not logged in, display login, and clicking on this would redirect to the login page. As you can see on our website, login. If you log in, the logout button is displayed, and then if you log out, the login button is displayed. Server-side and database programming. So in the Smart DCU data dashboard, the server-side programming acts like the brain of the application. It handles the data processing, storage, and user management and core functionalities that power the user experience. Server-side. So server-side programming refers to the code that's written in Java that is responsible for processing the sensor data collected in the project. The business logic of the server-side is referring to how the sensor data is displayed based on the user roles. So this is based on if a staff or a student logs into our program. The server code also interacts with the database to store the sensor data readings, manage user information, and retrieve data based on user actions or filtering criteria. In the Smart DCU Dashboard, MySQL stores the sensor readings collected from the sensors. During development, the MySQL database can be set up locally on the same machine where the server code runs. MySQL provides a solid foundation for data storage and management in the Smart DCU Dashboard project. So this is a demonstration of the temperature sensor class, which will be used to demonstrate the server-side programming of the Group A DCU sensor dashboard. So we use MySQL as the database, and then we have an API layer. So for this one, we use get. So we have a temperature sensor class, and in the class we have the following. Columns and rows in dot columns. So you have the ID, you have the time data, we have the room ID, and the temperature. So in the temperature sensor table, we first have an entity called temperature sensor entity. This class represents a data model for the temperature sensor. So as you can see, it includes room ID, time data, room, temperature, and also a room ID. We also have a repository, and this repository, it provides a method to interact with the entity table in the database. So this method is used to find all, so it returns a list of recordings for a room, it returns a list of recording by date, and then it records a listing by date since it records a date since the recording. We then have a mapper. So this is responsible for mapping between the temperature sensor data objects. So this allows for an instance of a mapper class and entity to model and model to entity. So this converts the temperature sensor model to a temperature sensor entity object, and it converts an object to a model object. Then we have the service. The service encapsulates the business logic for mapping the temperature sensor data. So this this retrieves all this temperature sensor data recordings and maps them to the model. Find by name finds their sensor recordings based on the name. Find by local date will find it by the date. Then this will also, if we want to get it from the last 24 hours or the last 7 hours, and this will post new sensor data to the repository, which can be saved to the database. Then lastly, we have the controller, which acts as a user interface between the client and the service. So this handles all the HTTP requests. So for example, the GET request. So this will retrieve the sensor recordings through the service and returns them as a response. You can get them by the specific sensor record, or post a new sensor recording by receiving the temperature sensor model object in the response request body by using the service to add it. So overall, these components all work together to provide a structure and manageable way to manage the temperature sensor data in our web application. And as you can see, in our web application, using the request, it gets the temperature from the database and then displays it in the daily average and noise level, the room occupancy. Now we're using a Postman and the SQL database to demonstrate how this works. So as you can see, on the localhost, on the user, first name, last name, username, password, and email are posted. Once you get a request of 201, this is a HTTP response to mean there is a success. Then, as you can see in our database, the first name, last name, the email comes up, and the correct names come up. User authentication login. So user authentication, this is the application that creates and maintains user sessions to manage access control. So user authentication is referring to verifying a user's identity through credentials, which is a username and a password in the Smart DCU dashboard. Upon a successful login, a user session is created and a session ID is assigned. So the benefits of a user authentication session and login is that only authorized users can access sensitive data and functionalities, personalized experience for certain users, and I will demonstrate this in our web application. So as you can see in our web application, this is the user login process. So the user will select between staff and student. So if I'm a student, I can enter an ID and I can enter the password and I can log in. And upon login, I have certain credentials that I can access. So I can access the temperature, the humidity, the noise level, and the room occupancy. Then if I log into a staff, I have a different access based on my credentials. So this is providing enhanced security through access control. So this means that depending on your user role, you get access to different levels of security in the program. Unfortunately, at the time of making this video, the code behind the user authentication wasn't able to be demonstrated, but as the project gets submitted, it would be implemented into the project. Program testing and deployment. So the program was tested to ensure that the Smart DCU dashboard functioned as intended and delivers a positive user experience. The program was ensured to be free of bugs that would prevent it from running, and any defects were reported back to the group. So for example, on the About page, it was noticed that some team members weren't present on the About page, and it was reported back to the group to improve and update the project before submission. The project was tested on different screen sizes to check if any errors in information displaying. Unit testing was used to test the server side in isolation using a postman, as demonstrated in the previous section. And the entire application was tested using system testing to ensure that the entire web app functioned as intended. Testing and deployment, Tomcat. So the web application was deployed to a Tomcat server, and this is the URL for the Tomcat server. So it was deployed using a WAR file, and the WAR file is like a standardized format for packaging Java web applications for deployment to servers like Tomcat, which is what you used. So the server unpacks the contents of the WAR file into a designated location and makes the application accessible to a specific URL. So a WAR file is essentially a zip file that will contain the Java class files, the jar files, the web resources, which is the HTML, CSS, Java, and the deployment description, which is the XML file, which configures the web application and has like servlets, filters, error handling. So Tomcat and the WAR file is a very good way to deploy the website. However, in production deployment, we wouldn't include the URL with this link for security reasons. We would just have domain name and then our web application name. So in conclusion, Group A successfully achieved the requirements for developing web application for a smart DCU dashboard, and it was demonstrated by using an audiovisual explanation. The navigation of the website, front end, back end, database relationship, login functionality, and testing QA and deployment was successfully demonstrated by using the screencast and diagrams.